result of energy production. And as it impacts all of us, and our demand for energy is increasing, that means more pollutant. Now we move as to greener energy sources such as wind and solar. But the problem is those energy sources are not available all the time because wind is not blowing all the time and sun is not shining all the time. So we need to be able to store this energy somewhere for later use. And that's where batteries come along. Batteries, energy storage devices, as we talk. And the batteries is integral part of our life, including from mobile devices and more recently for electric cars. But for problem with the batteries is that along using some highly precious metal, it's also the current batteries such as lithium-ion battery has limited storage capacity, meaning that it can't store as much energy as we like. And that's actually one of the turning point in electric cars. Many consumers want to buy electric car, even they don't care about environment, but they're like, how far I can travel? And so having higher energy storage devices, such as higher batteries, is highly desirable. And that's exactly why we've been studying the next generation battery, as we call it, lithium sulfur batteries. So one of the key features of lithium sulfur batteries, it has almost 4 times more theoretical capacity than the lithium ion, the current battery being. Also, sulfur is pretty abundant, and almost there is no concern of running out of sulfur, as also produced as byproduct of industrial processes, and hopefully it's cheaper to produce. But it's not that easy. So the sulfur battery, the main problem with it, it degrades very rapidly between charges and discharge cycles. After about 100 of cycling it 100 times, charging, discharging, 100 times, and it pretty much loses all its capacity that I bragged about. So that's exactly why our research focused on to tackling the degradation mechanism of the sulfur battery. So the first, our bigger goal of the research would be we need to increase the life cycle so it's practical to be able to use the battery. 100 cycle isn't great. So, and the first step would be to understand how it degrades and why it degrades. I think that those part the research mostly figured out. The next step is how do we prevent degradation of lithium sulfur batteries? Our focus, me and Sophia, although we did a lot of chemistry and we did all chemical formulation, but we are physics and engineers, so we naturally fall back into cathode coating optimization. And cathode is basic current collector, so all the batteries basically work the same principle. Sophia will explain more how we did construct cathodes, but we mainly focused on to optimize cathode coating, minimize defects, so we can gather enough data so that when we test our next generation battery, we can compare the data as like if any improvements has been done. And I'm gonna hand it to Sophia to explain about how we actually produce batteries.
Okay, so as Tosif briefly outlined, we can break our work down into 3 distinct parts, which is creating the cathodes, building the battery, and then testing the batteries. So we'll start from the beginning with the cathode coating process. So first we have to make a slurry or a paste-like substance, which contains our conductive material, which is carbon. So we'll coat aluminum several times in 2 lanes, like you see pictured in the top right corner. And we use a tool called a doctor blade just to create even coatings on both of the lanes. So this initial process is called our primer layer. And after going through a drying process in a pressurized and heated oven, we're ready to add our active material or the sulfur. So in order to do that, we create a slurry very similar to the first one. But like I said, this time we'll add sulfur. And again, using a doctor blade, we'll go ahead and run it through the aluminum on top of our primer layer. We'll let that air dry. And then once it's done, we'll be able to punch out our cathode disc. So you see our punch machine on the bottom right corner, and we punch out our cathode disc. Yeah, perfect. And then onto assembly. So to assemble the battery, we have to use something called a glove box, which is basically just a isolated environment that will block out our atmosphere or the air. And instead we replace it with argon gas. And we need to do this because lithium degrades very quickly and very easily in air and when exposed to air. So we're trying to seal it off from air completely. So in order to do that, we use the glove box. As you can see pictured on the top right, we have all of the components of our battery. Inside the glove box, we put each component, layering it on top of each other, and then use a crimper, which is also inside the glove box, to seal it, to make sure that it's safe to bring outside into air again so that we can run our tests. So then we move on to testing. We put our batteries into something called a cycler, which is basically just a machine paired with a program that will charge and discharge the battery. So one charge and one discharge is one cycle. We input some data like how much of that sulfur layer is on the battery, and that will tell us how much, or will tell the machine how much current to push through the battery. And then after we've done that, we just let it sit and it runs through its cycles. Okay, so as for our results, I actually had the opportunity to build the first lithium sulfur battery in our lab, which was super exciting, not only because it was the first, but also because it had a voltage coming straight out of the glove box, which was not something that we really expected. So our first results are promising. So as you can see on the graph to the right, we have some charge and discharge data on one of our functional lithium sulfur batteries. The red line indicates the charge or the voltage, and the blue line indicates current. So like I said, initially, it looks really good, but we're still making adjustments and experimenting. And that's also all to say that it is not our final product. We haven't solved our degrading or short lifespan of the battery yet, but we're hoping to do that with MOFs. So MOFs are metal organic frameworks, or like I already said, MOFs for short. And they're basically going to act as a net that will put over the sulfur. So one of the problems that we're having right now is that the sulfur, as the battery is being charged or discharged, the sulfur starts to separate from the cathode and it moves around the battery and it causes it not to work. We're hoping that the MOF will act like a net to trap the sulfur on top of the cathode so that we stop having that problem. So that is one of our big next steps that we're looking forward to working on. Other than that, we're also just looking to improve our battery assembly. It's really hard to put the battery together in the glove box because you have really big gloves and the batteries are very small. So just adjusting our battery assembly so they're more uniform every time. And then also just collecting more and more data so that we have a good set of baseline data for when we do eventually build our batteries that include them off. Okay, so my time at the lab has been really great. I've honestly loved being there the whole time I've been there. I've learned a lot of new lab techniques that I probably wouldn't have seen if I hadn't been part of this project. It was great getting to be part of like such a collaborative research project. And I also feel like through this experience, I've gained a lot of confidence in researching and also presenting scientific material.
Yeah, I also agree with Sophia, and I would add that it was my first time being in chemistry lab. Thanks to COVID, my chemistry lab totally was disaster. So this was first time I actually gained experience working in the lab, and also gained very comfortable handling all kind of lab equipment. Also, like, it's witnessing first-hand experience, like how research procedure works and all the research principles. Also, well, enjoy working with different teams with different backgrounds. They're like chemists, engineers, physicists. It was kind of interesting. Like, I learned a lot.
Yeah, and then just thank you to our mentor, to the SLI team, San Jose team. Thank you to everyone for letting us be part of this project.
Yeah, I'll say thank you to SLI, because that was probably the first step to get to the internship. Without them, I probably wouldn't be here. And thanks for the big donors. And then our Department of Energy funded this study. Also, Dr. Dillam has been very patient with us. So
Very.
thank you.
Thank you all so much, Sofia and Tosif. And yeah, we actually have time for maybe one or two questions. So does anybody have any curiosity about the work that Tosif and Sofia did? Tosif, you can go ahead and unshare your screen, and then we'll just see your faces. So anybody have any questions, either put in the chat. Yeah, so Marisa. Hi, Marisa.
Hi, Sophia. Hi, Tosif. I remember you both. So I know for both of you, this is your second research experience, and I'm wondering how you feel that you grew from this experience compared to the first. Like, how was it different and how did you grow?
I am less nervous because it was my second internship. The first one, I wouldn't have applied if you didn't insist that so in my physics class. But also the first one was remotely, completely different experience. I didn't go to the lab, just stay at home, do the programming and do 3D CAD design. This is different because it was multiple teams that working with teams.
Awesome.
Yeah, I feel like my first research experience was a lot more hands-off and honestly left me feeling like I probably didn't want to end up doing research, which I felt like was something that was good to know. But after this experience, I honestly feel completely different. I really enjoy hands-on work and I enjoy more experimental research and getting to be in places like the lab with like such an amazing team, and it's a collaborative effort. So I feel like it was a completely different experience in the best way possible.
Wow, we love to hear that. Awesome.
And I realized I totally, in the madness of getting this all started, I forgot to introduce you both. So on your way in, I'm going to introduce you. So this is Sofia Marquez, who is finishing up this quarter at Foothill. And she is potentially considering going to San Jose State in the winter. And Tosif is actually already at San Jose State, just started a week ago, and is continuing in the lab with Dr. Durham, which we always love to hear. So congratulations to you both. Thank you for kicking it off. And I have a question. Oh yeah. One last question.
Hi, Sophia and Tosif. My name is So-Young Park, and I'm on the board of directors for Foothill Foundation. And this is my first time being in SLI and seeing presentations by both of you. And I have to say, I'm sorry, I came in a little bit late, so I didn't get to hear Tosif speak as much, but Sophia, wow.
Oh, thank you.
We feel that way about all our students.
Yeah, so sorry, Tosif, I didn't catch your part, but Sophia, I just have to say, I'm really amazed by how well you're able to present and explain the process of what you went through. I'm not a scientist, but you helped me understand things like using the MOF and why that wasn't necessary with the degradation of the sulfur and all that. So it was really, I felt like it was useful for me to see that. So I just want to say kudos to both of you. My question is this.
Actually, we probably won't have time for a question.
Oh,
We're like really back to back.
Oh,
so,
sorry.
But thank you for your comment, if that's okay.
Yeah.
If you, I pack it in because we have 30 students doing presentations today and tomorrow, so I'm sorry about that. But thank you for your comment. That's really wonderful.
Well done.
Okay, thank you all so much. We're gonna move on. So I'm gonna remove Spotlight, and Vince David, if you could just go ahead and share your screen, and then I'm gonna highlight you as well. While Vince David is getting ready, I'll introduce him. So this is Vince David Nwego. The title of his project is Towards Reliable and Explainable Visual Assistance Using Data Science. He was interning with Li Liu of the University of California, San Francisco. Somebody, can everybody mute themselves? That would be great. And he is going to be returning to Foothill this coming fall. Aspiring data scientist. I'm gonna try to mute people. Okay, there we go. An aspiring data scientist applying machine learning and data-driven solutions for social impact and innovation. So Vince David, 7 minutes is yours, starting now.
Can you see it?
Yep, we're good.
Okay. So